Welcome to VAK's lecture. In this video, we will discuss about linear search or sequential search. I have included linear search in the array series because in order to implement the sequential search, it needs a data structure of which elements are in sequential form in the memory. So let us start the linear search. The method for linear search is very simple because in this we have to move in a sequential form only. We have to keep searching in the same form in which the elements are stored. So here I have taken an array of 6 elements. Here array name is A. Suppose I want to search for 22. So 22 is our searching element which I denote it as item. Now we will search it from the first element. Here the first element is 26. Do 26 and 22 match? They don't. Since they don't match, we just jump to the next element. Here the next element is 62. Now we will compare 62 with 22. Do they match? They don't. Since they don't match, we will jump to the next element. The next element is 51. Do they match after comparing? Still they don't match. Then we will again move to right. So the next element is 22. We compared 22 with 22. Do they match? Yes, they matched. So finally we found the item. Here we get the successful search. Suppose that the item that we need to search is 84. Up to 22, the comparison will be continued, but still they don't match. Then we will jump to the next element. It matched with 84 and our search is again successful. But if I take 88 instead of 84, then it searches the complete list but still doesn't get the item. Then our search will be unsuccessful. This was the simple method of linear search. Now, before going to start the coding, we need to write the algorithm. Let us see how its algorithm will work. There is a sequence of the algorithm, so I have written every step in a sequence about how it will work. In this algorithm, A stands for array from which we have to find the item. N stands for the total number of elements. Then the item is that we need to search for. So we have given 3 things on the list. Also, we took a local variable here named LOC for the location. That is the location of the item we have to search for. So the index of the location where we will find it will be returned. And we define the local variable -1. -1 means that the searching process is unsuccessful. If we don't find the item, then it will return -1. And we have taken here I. What is this I? I is a variable for the index. So I will start from 1 and go to 2, 3, 4, 5 and then 6. That means it will go up to n, which is the total number of elements of the given array. And here we started I with 1. You can do it from 0 also. But I started it from 1. If you start from 1, then the loop will continue up to n. So the condition will be I less than or equals to n. If you start from 0, then you have to move up to n minus 1. So the condition will be I less than or equals to n minus 1 or I less than n. Next, here we use the loop because we want to repeat it. But how? First we go to this item, then we go to the next with an increment of 1. Then we will again jump to the next with an increment of 1. This way we have to search the end of the array. There will be 2 conditions. First is we have to start from here and reach up to here. So we put a condition that the I must start from 1 and keep working until the array ends. That means I less than or equals to n. And we have put the second condition by using logic and operator. It is used to verify whether the A of I or the element to which we have reached is equivalent to our item or not. It will keep running until the search gets equal to the item. It will keep running until end of the array. You must be knowing how AND logic works. It will check this condition first. If it appears to be true, then only it will check the next condition. Otherwise, if it is false, it will get out of the loop. Now, let us understand the algorithm with this example only. Suppose that we need to search the item 51. So, see here, if I is 1, then the condition is 1 less than or equals to n. Here, n value is 6. So, 1 less than or equals to 6. Then the condition is true. Then it will check this condition. Here, a of I is 26. So, 26 doesn't equal to 51. This condition is also true. So both the conditions are true. So that we will enter the loop. And what do we have inside? We have incremented the index. The value of I is 1, but now the value of I will be 2. It will again compare with 6. Since this is true, it will check for the next situation. The value of A of I is 62. So 62 doesn't equal to 51. So both are true. So that it will again enter the loop. The value of I was 2, but now it will be 3. It will check again and the condition gets true with 6. Next, the value of A of I is 51. So 51 not equals to 51. But this condition is false because 51 equals to 51. So it will get out of the loop and jump to the step 4. Does the value match with 51? Yes, it does. So the location will be I. The value of I is 3 at this moment. Since search is successful, so it will return 3 in step 5. And if we keep incrementing the value of I but still don't find the value, then it will directly get out of the loop and checks whether it matches or not. If it does not match, then it will return the location. What was the value of location? It was -1. That means we didn't get the item. So the attempt was unsuccessful. So if it is unsuccessful, it will return -1 only. So this was the algorithm for linear search. And if you got to learn anything from this video, please like the video, share to your friends and subscribe my channel, and also press the bell icon for more new updates. Thank you.